Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture, we are going to discuss about the implementation of CartPole environment. So CartPole is one of the gymnasium environment that we discussed in the previous lecture, and we will discuss the implementation. We will not go with any reinforcement learning algorithm, but we will build some random agent using Python. So first step is first step is create a CartPole environment first. Create CartPole environment. So how we create the CartPole environment? If you want to create a CartPole environment, first we have to import the gymnasium library. So import gymnasium as gym. So import the gymnasium library. Now create environment, CartPole environment. So env environment equal to environment, right? Env equal to gym dot make. So we have to pass the CartPole environment. So for to pass the CartPole environment, that name that we discussed in the previous lecture also. So case sensitive CartPole-Python v1. Okay, so like that we are creating the environment. So you can write print like CartPole environment is. So you can run this cell. Yes, the CartPole environment is created. So to create the CartPole environment, first we need to import the gymnasium library, and from the gym you have to call the CartPole v1, that is called the CartPole environment. So that will help you to create the CartPole environment. So in this environment, what you contains the cart. So this is your cart, and you have the pole, and this is your pole. Your goal is the pole should be balanced and it should be upright. And two actions, one action is the movement of the cart right side, another action is movement of the cart left side. And you got some rewards for every move while balancing the pole, not to fall your pole down. So then you got the reward that we called as +1 that we discussed in the previous lecture. And the termination criteria. What is the termination criteria? If the pole fall down, then the episode ends, your algorithm stops, your agent stops. And second one is, let us assume while running the algorithm, I give the 100 episodes. The maximum timestamps reach, then also your learning process stopped automatically. So that is called as the termination criteria. Termination criteria based on the maximum iterations or maximum episodes. And another thing is when the pole is fall down, then also it is terminated. So coming to the observation stage, as I said in reinforcement learning, you have the one of the parameters that is called as the state. The state will represent the state of the agent, condition of the agent, position of the agent. So what is that state? So the state or observation, both are same. Observation or state, both are same. So state of the agent, nothing but the cart, is represented with the 4 numbers. In CartPole environment, state are nothing but the current position of the agent, nothing but the cart, is represented with the 4 values. The first value represents the cart position, where cart is located. Second value represents the cart velocity, with which velocity cart is moving. And third position represents the pole angle. What is the pole angle? It is the straight, and this is the angle. What is the pole angle? And last parameter represents the what is the angular velocity of the pole, because your pole will be shuffling. So what is the angular velocity of the pole? That will represent. So this is these 4 values will represent the state of your CartPole, your agent. So hope you understand. Now we will discuss the second stage, that is called as the reset environment. How we reset environment? So then you have to write state, comma, info means it will provide some information. If any information is there, that will provide info. That's equal to, so what is our environment? env dot reset, env dot reset. Okay, now you can print state and also you can print info. Okay, now see, yeah, so when you reset the environment, it provides the initial state of the cart. What the first one represent? So this will represent the cart position, this will represent the cart velocity, this will represent the angular position of the pole, and this will represent the angular velocity of the pole. So these 4 parameters will represent the observation or state of your agent. And additional information, if there is any additional information, that will be printed. There is no additional information as of now. So clear, I hope you understand as of now. So now next step, it is about the action space. So we understand the states. In reinforcement learning, we need the information about the rewards, we need the information about the state, we need the information of the actions. So state information is already available. So now we are moving to the action information. How we got the action information, that we will discuss now. Action equal to env dot action space. So env dot action space. So we'll see what we will get from here. env dot action space. So what? Yeah, you can see. So action equal to env dot action space print action. It will give the discrete values. It will give the 2 values. It may be a 0 or 1. So I think 0 means move cart towards left, and 1 means move cart towards the right. So left movement represents with the 0, right movement is represented with the 1. So that's why it represents the discrete to it. The discrete, it contains the 2 values, 0 and 1. 0 represents the left action and 1 represents the right action, left movement and right movement. So this is called your action space. Okay, so next one is, now we will move to the random action. So how we get the random action? So this is the action, 1 and 0 or 1. This will represent what the action space will be. The action space contains a 0 and 1. 0 represents the left movement, 1 represents the right movement. But in reinforcement learning, I said agent will took the some random action. It may be a left, it may be a right. How he took the random action? So that we will discuss here. Random action. So random action will be action equal to env dot action underscore space dot sample. Some random action will be generated randomly. So you can print action. So otherwise we can write, so what action will be? Action will be either 0 or 1. Right? So suppose if action is equal to 0, then you can print cart moves left. Okay, so right. So another one is, we can take another one like if action equal to 1, then what does it mean by action equal to 1? Then what it mean by? So cart moves towards right. So now you can see. So cart moves right, that means action equal to 0. And if you run again, cart moves right, so that action equal to 1. If you run again, cart moves left, that means action equal to 0. That means, so like that we will generate the random action. So the A agent chooses a random action, moves left or moves right. Okay, how we choose the random action, how the random action will be generated, like this. So that is the env, that is the environment dot action underscore space dot sample. So it will give the right movement or left movement, right? So once that movement was happening, once the agent took the action, either left action or right action, then that action will be applied on the agent by the environment. That should be applied on the agent by the environment. Then once that action is applied, then it will give some outcomes, like what will be the next state, what will be the action taken, whether it is a terminated, that means falling is happening, or it is a truncated, maximum efforts are reached, and what is the reward. That information should be provided. So that we will discuss next. Now how the action will be implemented, that we will discuss. I want to do it from the scratch for simply understanding purpose. So import import gymnasium as gym, and we have to make the environment. So env equal to gym dot make of, what is the environment, cart pole hyphen v1. Done. So environment is created. So once the environment is created, now reset that environment. So reset the environment means it will provide the current state of the agent of the cart, and it will provide some random information that's equal to env dot reset. Okay, so that's the second stage. Now I want to print the current state, that means print. So in the current state, first value will be, so in the current state first value will be cart position. So cart position. So what is the cart position? The cart position is given by, from the current state, from the observation from the current state, you can see the first one, 0th index is a cart position, 1 index is a cart velocity, 2 index is a pole angle, 3 index is a pole velocity. So that information I want to extract. State of 0, that will represent the cart position. Similarly, you can get the cart velocity. So it will be 1 then. And next one is pole angle. So this will be the index 2, that is the third position. And next one is pole angular velocity. Pole velocity or pole angular velocity. That is the last one. So I want to print all this information. Okay, now you can see, that's it. So this is the cart position, cart velocity, pole angle, and pole position. Done. So this is the, so I want to keep it as a reset environment. Okay, and these all are the I can write print. These all are called as initial state information. So print initial state information. Okay, and that's all. So this is the initial state information. Now, so what next? We have to discuss about the, now this is the initial state. So now we have to include the some random action. Okay, so action. So I will write here random action. So now for the random action, so action equal to env dot action underscore space dot sample. Okay, underscore sample. So it will give the random action. 0 means left, 1 means right action. So we will see that also we will print. So what action it is chosen. So not print, sorry. If action is equal to 0, then it is a left. Cart moves left. Cart moves left. Okay. So and the action equal to 1, the action equal to 1, then it will the cart moves right. Cart moves right. So this is the initial positions, and this is the based on this is the random action state that is generated. So cart moves left. So it is suggesting cart moves left. Fine. Now once the random action is completed, now we have to, that means agent chooses the that means cart chooses to go left. Cart chooses to go left. Now environment is applied that action on that agent. Environment applied that action on that agent. When the environment applied that particular action, left action on the agent cart, then the cart position will be updated, state will be updated. Then what's the next state? That we will discuss. And moreover, this is the current state information. Okay, current state information we have already. So now coming to the next state. So next state. So that means when the this is the cart moves left, this is the action, the agent, the cart chosen. So then environment should be applied. Once the left action is applied on the cart, on the agent, then the state will be changed. Then what the next state that we have to print? And based on the next state, your agent will got the reward. Agent will got the reward. And it got the information about the terminated. Terminated means if your pole fall down, then it will be terminated. Truncated. Truncated means if the maximum episodes are reached, it is truncated. And finally rand information that's equal to, now we have to call env dot step. That means apply the action what is generated here. What is the action generated here? You have to apply. That means environment applied this action on the agent, on the cart. Then based on this action, then the state of the cart will be changed. So it go to some other new state, and based on the new state it will got some reward, and it also check whether it is a terminated or it is a truncated. That information also checked. Now you can print that information. Next state. Now this is the next state, right? Now I want to print all this information. So these are the current positions, initial state. Now these are the next state information. Next state information. So I can write it as a next cart position, next cart velocity, next pole angle, and next pole velocity. But here it is the next state. Current state is the old previous one. Next state now. Now you can see what happened. So initial states are these: cart position, cart velocity, cart angle, pole angle, pole velocity, and these are the next position, next cart position. That means once the action, left action is applied, these are the new positions of the cart. You can see here it is 0.0307, here it is 0.0303, here it is a minus 0.01, here it is a minus 0.21. So this is the previous state, and now it is the current state. That means now it becomes a current state. It is the initial state. After this action, this is my current state. Next state will become a current state, right? So hope you understand. So after action, this is the state I'm getting. Okay. So and also we can print other informations like what is the reward. Okay. So we can print that also. Print reward. So what is the reward here? You can write reward, R-E-W-A-R-D, reward. So you can run this one. So reward is 1. So it is getting reward of 1. That means if the reward is 1 means you are not truncated, you are not terminated. If it is terminated, that means pole is fall down, you are not getting anything. Now see the status of the terminated and truncated status information. So print that information also. So terminated information, and similarly check the truncated information also. So truncated falls, that means maximum number of epochs not reached, and also terminated fall, that means your pole is not fall down, and this is the your initial state. After applying the left action, this is your current state or next state. from this position. For this position, this is the next state. So it is the current state. It's like that how environment applied a particular chosen action onto the cart, and once the action is applied, how the states will be updated, how the rewards will be coming. So this is what I'm trying to discuss about the action implementation as part of the random action implementation as part of the stage 4. And next step is we will generate the random agent. We will prepare the random agent. So whatever the steps I am following, the same steps will be repeated for all the environments also. Same steps will be repeated for all the environments also. So coming to the random agent, that means I have to train this card for the 10 epochs, 10 episodes or 20 episodes. So during the 10 episodes or 20 episodes, so this is the initial state, and random action should be applied. Based on the random action, it got some reward and it got a new state, and this next state becomes a current state, and again apply the random action and it got the reward and state will be updated, and this next state will become a current state. So this process will be repeated. This process will be repeated. So when this will be stopped? When the pole falls too much. Pole falls too much. That means your pole angle is very large when compared to the threshold value. Cart moves out of the track. Cart moves out of the track. Or time limit reached. That is called as the truncated. So these are the three conditions when the episode starts. When the episode stops, when the algorithm stops. When the pole angle is too much, that means your pole is fall down. And when the cart moves out of the track, or the time limit is reached, this is called as the truncated. So goal for the random agent is survive as long as possible to collect the +1 reward for every time. How many steps, how many steps the random agent, random cart taken, so that for every positive step, successful step, that means your angle is not far, for a cart angle is not far, not high, that means it does not fall down, then every time it will got the +1. So goal is reach the maximum rewards. Reach the maximum rewards. It got the rewards +1 for every successful move. Successful move means your cart angle, your pole angle is not higher, it not fall down. You got the +1. So it's time to maximize it. So that part we will implement now step by step. Now we will discuss how we build the random agent. So import. So first all the steps we will add. So first step is create an environment. So to create an environment, first import gymnasium as gym, and create an environment env equal to gym dot make CartPole environment CartPole -v1. So you can type print environment here. Done. Now we need to reset the environment and get the initial states. So we already have the information. I will directly call that how we reset the environment. So all is created. Now I want to reset the information. Where it is? Yeah, reset the information. So next step is reset the information. Otherwise, I will write first step is create environment. Now after creating the environment, so we have to reset environment. How we reset the environment? That is called current state, that is called observation info is equal to env dot reset. Then you can print the current state information. Like we already have this information, right? So this part we have to print. So that means reset the information. Done. Okay. So this will give the current position or current state of my agent, that is the cart. Now what we will do? So this process will be repeated. Let's assume I want to learn the cart agent for the 20 episodes. So I can create episodes episodes equal to 20 episodes, and assume total reward initialize as 0. At the point of time there is no reward to the agent, total reward equal to 0. Now what I have to do, so episode 1, choose some random action, apply the action, collect the reward. Next, episode 2, choose the random action from the, see, one more thing, episode 1, choose random action, apply the random action, then collect the reward, and you got the new state. And you have to collect the reward, update the total reward, and you got the new state. Now this new state becomes a current state. New state become a current state. Okay, so this process will be repeated. New state becomes a current state, and this process will be repeated. So how it will be coming? So you can see for episode in episodes, episode in episode. So what we have to do now? First, so we have the current state information. Okay. Now we have to choose some random action. So action, the agent will choose, not we, agent will choose some random action. So that is called env dot action space dot sample. It will choose some random action. Okay. So we said if it is a 0, it will be left action, or it will be 1, then it will be right action. So I want to choose this one directly instead of taking everything again and again. Text. Done. Okay. Now what we have to do? So action is coming. Now we have to implement that action. So how we implement the action? By the environment. You can see here. This is how we are implementing the action. So this is the next state, and everything will be available. Reward, terminator, everything will be available. So you have to, after this is the action chosen by the agent. Now environment will be applied. Environment applied that state on that agent. So once that action is applied on the agent, on the cart, then the state will be updated. Now the next state, these are the informations, rewards and everything you are getting. Okay. Now, so it's not required. Okay. Okay. Reward and everything. Now, once we got the reward, we have to update the total reward. So total reward equal to total reward equal to total reward plus reward, whatever the reward is getting. So that is the reward considered here. So we are getting the total reward continuously. If the algorithm is terminated, that means fall down or truncated, maximum time reach, then you can break, you coming out of it. Okay. Otherwise, so what we have to do? Otherwise, what we have to do? Current state whatever the next state we are getting here, that will become a current state for the next episode. Right? And also you have to print here something like print some information like format string. So which step it is? So which episode? Otherwise episode. Better keep episode episode. So episode equal to episode plus 1. It's a printing. And what else? So next state everything is printed. I don't want to go that one. I want to go with reward. So reward equal to reward I am getting, and what the reward is getting, that's also printed here. And what we can print, and if you want we can print the current state and next state also. Current state current state, and next state equal to next state equal to next state. Anything else? I think it's sufficient. What the reward and everything. At end we can print the what the total reward we are getting. So I hope it's fine. If it is truncated, a terminate will break it coming out of it. Otherwise, this loop will be repeated. We'll see how it will work. Done. Now it's showing some error where it is. For episodes, sorry. So here we have to write the range of episodes. So I want to decrease the number of episodes for only 5. I want to take. Yeah, you can see. So you can see episode 1 getting the reward 1. This is the current state and this is the next state. And episode 2 reward 1. This is the current state and this is the next state. You can see here the next state of the previous episode will become a current state of the current episode, and this is the next episode. So again episode 3. So like that it will be printed. So this is for the episode 5. Okay. Now what I want to do is I want to print. So total reward, how much it is getting, the cart or agent getting total reward. So print total reward is equal to, print total reward is equal to, so what is the total reward? This is the total reward, and also print average reward. Print average. So this is the total reward, TO total reward, and this is the average reward over 5 epochs or 5 episodes. So average reward equal total reward divided by episodes. How many episodes are there? That you have to keep total number of episodes. Now you can run this one. And finally, you're getting the total rewards equal to 5 and average reward equal to 1. So this is how your random agent learn. You can increase 10 episodes, then you can run this one. So I got the total reward of 10 and average reward of 1. That means over 10 episodes, the cart able to maintain the pole upright without fall down. That's why every time it is getting the reward of 1. If it is fall down, even though you are giving the 10 episodes, but it will be break and your reward will be less than 10. If it is fails, if the fall, if your pole is fall down. But here pole is not fall down over 10 episodes, so that every time it is getting the reward of 1, 1, 1, and so total reward equal to 10 and average reward equal to 1. So hope you understand how we build the agent, CartPole agent using gymnasium environment using Python. So this is our flow. First you have to create an environment. You have to reset the environment and understand the actions and take the random action and prepare the random agent. So these are the steps we discussed in this lecture till now. So hope you understand. In the next lecture, we will come up with a new environment that is called the mountain car. So until then, bye. Thank you.